We now discuss the solution of a problem from the section coordinate geometry. This problem is on the locus in the context of a given ellipse. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is the locus of the midpoint of the line segment joining the point with coordinates 4, 3 and the points on the ellipse x square plus 2y square is equal to 4 is an ellipse with eccentricity. We are given 4 options. Option A, root 3 by 2. Option B, 1 by 2 root 2. Option C, 1 by root 2. Option D, 1 by 2. We are given an ellipse x square plus 2y square is equal to 4. We are given a point 4, 3 and the locus of the midpoint of the line segment joining this point 4, 3 and the points on this ellipse. It is given to be an ellipse and we have to find the eccentricity of this ellipse. The eccentricity of the ellipse that is obtained as the locus of the midpoint of the line segment joining the point 4, 3 and the points on this ellipse. We now discuss the solution of the problem in detail. Let capital P with coordinates 4, 3 be the given point. Let capital Q be any point on the given ellipse x square plus 2y square is equal to 4 and putting the equation of this ellipse in the standard form of the equation of the ellipse as x square by a square plus y square by b square is equal to 1. Then we get x square by 2 square plus y square by square root of 2 square is equal to 1. The coordinates of Q in parametric form are Q given by 2 cos theta, comma root 2 sin theta. For a standard equation of the ellipse x square by a square plus y square by b square is equal to 1, the coordinates of any point in the parametric form is given by a cos theta, comma b sin theta. Following that, we get the coordinates of Q in the parametric form as 2 cos theta, comma root 2 sin theta. Now, we have to find the midpoint of the line segment joining P and Q. So, let M be the midpoint with coordinates h, k be the midpoint of the line segment PQ. We first find the locus of this point h, k. Now, h, k is equal to the midpoint of P 4, 3 and Q 2 cos theta, root 2 sin theta. And the midpoint formula we are using 4x1 plus x2. 4 plus 2 cos theta by 2, y1 plus y2 by 2, 3 plus root 2 sin theta by 2. So, these are two ordered pairs or they are equal, therefore the corresponding entries are equal. So, that will imply h is equal to 4 plus 2 cos theta by 2, cancelling 2 both in the numerator and denominator, we get h is equal to 2 plus cos theta and k is equal to 3 by 2 plus 1 by root 2 sin theta. Correct. And this will imply h minus 2 is equal to cos theta and k minus 3 by 2 is equal to 1 by root 2 sin theta. Therefore, sin theta is equal to root 2 times k minus 3 by 2. Now, we eliminate theta. How? We know cos square theta plus sin square theta is equal to 1. Eliminating theta, we get h minus 2 whole square, that is cos square theta, plus sine square theta, that is root 2 into k minus 3 by 2 whole square, that is 2 into k minus 3 by 2 square is equal to 1. And writing this as h minus 2 whole square plus k minus 3 by 2 whole square by 1 by 2. Yeah, this 2 is written as 1 by 2, that is equal to 1. The locus of h comma k is given by replacing h by x and k by y, we get x minus 2 square by 1 square. So h minus 2 whole square by 1 square, that is x minus 2 whole square by 1 square plus y minus 3 by 2 whole square by 1 by root 2 square. That is putting in the standard form and of an ellipse. So right, we continue in the next slide. And we have the locus of h comma k, which we have seen in the earlier slide. X minus 2 square by 1 square plus y minus 3 by 2 whole square by 1 by root 2 square is equal to 1. What is this? It is an ellipse with the center at 2 comma 3 by 2 and the semi-major axis is 1 and the semi-minor axis is 1 by root 2. So it is an ellipse with center at 2 comma 3 by 2 and A is equal to semi-major axis is 1 and B, the semi-minor axis is 1 by root 2. Obviously A greater than B. Yes. Now the eccentricity of this ellipse 1 is given by E is equal to under the square root of 1 minus B square by A square, A greater than B. Therefore we take this formula and that is equal to under the square root of 1 minus B square. B is 1 by root 2 square by 1 square, that is A square. That's equal to under the square root of 1 minus 1 by 2. Agreed? And 1 minus 1 by 2 is 1 by 2. Under the square root of 1 by 2 is 1 by root 2. That is the eccentricity of the locus of the midpoint of the given point P is equal to 4 comma 3 and any point on the given ellipse. Right. So that is the one. So let's look at our options. Our answer 1 by root 2 appears against option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem on the locus in the context of a given ellipse. And it is not a difficult problem. It is definitely an easy problem. I am sure that you have understood the solution of this problem and I wish you all the best. Thank you.